For the next few examples, we are just going to use the techniques that we have learned, that we have discussed, and apply them to different situations. And what I want you to do is I don't want you to get overwhelmed when you see a problem like this, which looks very complicated, but take things step after step, and they're going to get way easier as you go along. All right. I'm going to call this entire part other fun factoring, right? Because it's fun, isn't it? I can't hear you guys. Isn't it fun? It must be because you're not in the classroom, you're actually sitting at home watching these videos, and I'm sure right now you're shouting out, yes, Mr. Fieser, this is fun. I agree. I agree. So, let's look at our first example. What is the first thing that we always do? We try to find a greatest common factor. So let's look at the numbers, 24, negative 6, and 3. They have 3 in common. Let's look how many x's the three terms have in common. The smallest exponent, lowest exponent is squared, so we got x squared in common. Let's look at the y's. We only have y to the first power as our lowest term, and there's our greatest common factor. Everything else goes back inside, and then we take another look, which gives us 8xy minus 2xy to the sixth plus no more coefficient and no more x squared and no more y. So just another placeholder, positive 1. Looking at what we have left inside there, we cannot really do anything. The exponents don't work, the variables are all mixed up. So we're actually done. See, that wasn't too bad. Let's look at the next one. Again, that looks very complicated, but believe it or not, if we just follow our target sum, target product approach, and remember that we have to split the middle term because of the exponent of our x squared term, we will be just fine. Okay. Our target sum is 5. The target product is negative 24. And that leads us to the numbers 8 and negative 3. Write everything down, splitting the middle term. 2x squared plus 8xy minus 3xy minus 12y squared. Remember that splitting the middle term doesn't change the value of our polynomial. We're just kind of like taking that middle term, pulling it into two pieces. And even if one piece now is negative, if you put them back together, you get exactly what you had before. Let's go ahead and factor our first group together, and we get 2x that we can take out. X plus 4y goes back inside. Then, let me change my color here. Of our second group, we can take out negative 3y. And what remains? A positive x, a positive 4y. Look, what happened? Our parentheses look the same, means we did everything right. Our final answer is x plus 4y times 2x minus 3y. Skeptics, always feel free to check your answers by FOILing, by multiplying them again, first term by first term, first by outer, inner by inner, and last by last. And you will end up with the same trinomial that you had on top. That's a technique, and that's just a regular thing, checking your answer, and you're always welcome to do that. Moving on to our next example, the first thing we see right away, 3x to the fourth power minus 3, we have the greatest common factor. Take that out to see things more clearly, and that's really what it is, right? because now we have x to the fourth power minus 1, and that looks kind of a little bit like the difference of perfect squares, right? We wish there was an x squared and not just an x to the fourth power. But if we think about that, then we can say, wait a minute, we got an even exponent. Even exponents can be divided by 2. So we can say that x to the fourth power minus 1 is really x squared squared again. Remember, the power rule of exponents means multiplying those exponents will give us back 4. And we got minus 1 squared. And now we can say a is x squared, b is 1. And we can treat this like a difference of perfect squares. And now we're going to get 3 times x squared, which is our a, minus 1 times x squared plus 1. And believe it or not, looking at this, we see that we have another difference of perfect squares now. This one is also a difference of perfect squares, right? This is x squared minus 1 squared. So now we can use x for a and 1 for b, and rewrite that whole thing into x minus 1 times x plus 1 times x squared plus 1. And remember, sum of perfect squares does not have a pattern. Our last term in parentheses here, our last expression, I should say, cannot be factored anymore. But this looks pretty factored to me, don't you think? Circle around it. Well done. And moving on. 2x to the fifth power minus 14x cubed plus 24x. And again, the first thing we do is we find a greatest common factor, which is 2x. This leaves us with x to the fourth power minus 7x squared plus 12. Now we're thinking, we have really high exponents again. But looking at the previous example where we just decided that we can take x to the fourth power and turn it into an x squared, which is again squared, let's rewrite this. Only the part in the parentheses now, up here real quick to see what that would give us. We have x squared squared minus 7. I'm going to put parentheses around the x squared just for a moment, plus 12. So the x squared is something that we can just treat as a variable for now, and then go down and use our target sum, target product approach. Target sum is negative 7, target product is 12. From these two lucky numbers, we find out that the numbers we need for our factors are negative 3 and negative 4. Look at the term that we wrote up above the example. Our first and squared term, squared in quotation marks I should say, has an exponent of 1. So we're pretty much done. We don't have to split the middle term. So let me rewrite this. The full thing now with all our factors, we got 2x times. Now we use x squared for our parentheses, minus 3 times x squared minus 4. Now you could say, well, we're done. But as soon or whenever you see parentheses with an x squared and a minus in there, it's always important to check, do we have a difference of perfect squares? And guess what? This one is the difference of perfect squares. So our final answer is 2x times x squared minus 3. 3 is not a perfect square, so nothing else to do here. Times x minus 2 times x plus 2. And this is a fully factored answer. Well done, you guys, and I will see you in class.